Hey everybody. So if you have been following my channel for any length of time, you may have seen on one of my live streams with Isaac that I had purchased a new camera. So it is June right now, so about 2 months ago I purchased a ZWO A294 monochrome camera. So between that time and now, I've had an opportunity to test it out and kind of learn the nuances of that camera. So in this video, I thought what I'd like to do is just kind of go through what I found as pros and cons, the nuances of the 294, and then show some of the images that I was able to get out of the 294 once I figured out how to actually kind of do flats and that kind of stuff with the 294. Well, let me go ahead and show you guys the primary configuration that I had the 294 mm Pro in its configuration while I was doing this testing. So I had to buy a whole new set of filters. So I am using the Antlia. In this setup here, I'm using the Antlia 4.5 nanometer SHO filters and the Optolong LRGB filters. 7-position filter wheel. I opted to go with the 36 millimeter filter wheel, like the one I have on the 2600. That way, if I wanted to ever swap filters between the 2600 and the 294, all I had to do is just take the filter wheel and just swap the filter wheels, because then I could use a slightly wider bandpass on the 2600 if I wanted to. So what do I have here? I have my trusty old 8-inch Orion ritchey-chretien telescope. The focal length on it, native focal length, is 1600 millimeters at f8. I do have an astrophysics reducer on it, which brings the, it's a 0.72x reducer, which brings the focal length down on the RC from 1600 to 1152 millimeters, so 1152 millimeters. And the focal ratio is right around f5.7. I've got my Orion 80 millimeter short tube refractor on as a guide scope. This little telescope is a 400 millimeter telescope with a focal ratio of f5. And then on the back of that, I have my trusty old Orion Starshoot auto guider, which has served me well and I've had for well over 10 years. And then that was all pretty much sitting on top of my Atlas EQG mount inside the observatory. So I don't think I forgot anything. And then, of course, the 294. So let's go ahead and go inside, and I will show you guys what I've come to find is the ZWO ASI294MM Pro. Right, so why did I pick the 294 over other potential monochrome cameras? So I already had the 2600, which is an APS-C sensor size camera. So it's a fairly large sensor. What I was looking for was a camera with a slightly smaller sensor so that I could get a narrower field of view when using my telescopes. I wanted to use it with my longer focal length telescopes Particularly, I wanted to use it with the 8-inch RC. With the reducer, the 8-inch RC comes in at 1152 millimeters. So that and the 2600 gave me a rather tight image scale that I needed very, very good guiding if I wanted to get quality images. So if I went on ahead and looked for a camera that had larger pixels, I could actually not have as good a guiding, still good guiding, but it would just give me that much more of a chance of capturing good data. So the 533 I looked at, but it had the same size pixels as the 2600. The 183 has a much smaller pixel size, and we'll get into that in a little bit. And the 294, interestingly enough, has 4.63 micron pixels in its native bin 2 mode. So the pixel size of 4.63 micron paired with my RC when running it with the reducer at 1152 millimeters gave me a image scale, a very nice image scale, where I think my guiding needed to be 0.83 or better, and I was able to achieve that no problem. So so that's why I went on ahead and went with the 294. The other interesting thing with the 294mm Pro is that you have the option to unbin its native bin of bin 2. And what that means is you can actually drop it down to bin 1, which gives you 2.31 micron pixels, which makes it very similar in pixel size to the 183. The 183 is very good with shorter focal length telescopes. So I figured if I got the 294, I could unbin it down to bin 1, and it would be like I had two cameras in one, both 183 at the 2.3 micron pixels and the 294 at the 4.63 pixels. So that was pretty much my deciding factor as to why I went on ahead and chose the 294. So let's go ahead and move on to the computer, and we can go over what I found out, how I needed to take my flats, what type of calibration frames I needed to take to get good quality images out of the 294. So one more thing real quick. So go ahead and like, subscribe to my channel, leave me a comment on the video, let me know what you think. Oh, and also I want to thank you guys for watching. I really appreciate each and every one of you guys. Without the viewers, my channel wouldn't be anything. So as little as my channel is right now, I really appreciate each and every one of you guys out there watching my content. So thank you very much. Okay, so let's go over to the tech specs of the 294. The 294 uses the Sony IMX492 CMOS sensor. It is a 4/3 chip, like I said. The standard resolution at in bin 2 is 4,144 pixels by 2,822 pixels. It is a 14-bit camera. Read noise is pretty good. Cooling temperature, it'll cool down 35 degrees below ambient temperature. And the pixel size is 4.63 micron pixels in bin 2. So for bin 1, the resolution goes up to 8,288 pixels by 5,644 pixels. The pixel size is then 2.3 micron pixels, or 2.31. So unlocked in bin 1, it is a 12-bit ADC, 2.3 micron pixels. It's a 47 megapixel camera at that point. Resolution again is 8,288 by 5,644. The full well capacity is only 14K. Bin 2 again is a 14-bit ADC, 4.63 micron pixels. It is an 11.7 megapixel camera with 4,144 pixels by 2,822 pixels. The full well capacity is 66K. So when in bin 1, your file sizes are going to be a lot bigger. I think when I ran in bin 1, the file sizes were like 89 megabytes. So that's a pretty big file. So with the 294, there is amp glow. So you are going to need to take good dark frames. And also, another thing that you need to worry about is flats. The flats, so I struggled with the 294 flats a lot. I went back and forth. I must have shot 70 different batches of flats trying to find the right flat. So interestingly enough, with the flats, out on the ZWO web page for the 294, there is a Q&A section, and one of the questions does ask about flats. So right here, question 2, it says, I've heard there might be strange patterns on some 294 Pro stretched images. Does this mean the camera is defective? The answer is no, it is not a defect, and it is just a characteristic of the sensor. The patterns calibrate out of the light images with proper flats. And then here's where it tells you what you should be using, or how you should be getting your proper flats. So a proper flat frame is captured using an even illuminated blah 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 blah. So yeah, we all know that. An average ADU of 24,000 is recommended, or that's what ZWO recommends. And here they're saying that this is an example of a 5-second exposure here, and they're saying that the histogram peak should be at 1/3 to 1/2 from the left. So I was experiencing these issues with flats, so I had to work really hard at getting my flats to be exposed over 4 seconds. Because after talking to people on some of the forums, looking at cloudy nights, talking to people in Discord, and just some other people out there that had a 294, they were all telling me that yes, your flats needed to be this specific ADU, and with an exposure time of at least 4 seconds. So that's what I aimed for. And that's what I was able to achieve. So I think my ADU that I found was best for me was 20,000 K, and exposure times anywhere from, I would say, 4 seconds to 6 seconds is where my flats landed. Okay, so here we are in PixInsight. So I just have a couple frames here that I just wanted to show. So the first one, this is a stacked image of NGC 6888, the Crescent Nebula. These were 10-minute exposures, so this was a stack of HA data. Now this stack was just the lights, so I wanted to show the amp glow in a stacked light. So we open this up. So right here, as you can see, right here in this area over here, you can see the starburst. So this is where our amp glow is. So you want to take darks to get rid of that amp glow. So I'm going to show you a master dark, and this is a 600-second master dark. So this is the darks that I used as my calibration frames for darks for this this image. So right here, now this is just the regular auto stretch in PixInsight, so it's probably a little overkill, but you can see the starburst here, you can see a starburst over here, and you can see some corner amp glow over here. So there definitely is amp glow in the 294. Obviously, the longer the exposure, the more amp glow you're going to have. I didn't see as much amp glow with say 120-second exposures or 180-second exposures, but definitely with a 10-minute or a 600-second exposure. My master flat, again, just to show you the flat that I actually was able to grab and finally worked out. So this is a flat for me, and I'm not sure which one this is. I want to say this might be luminance or possibly HA, but again, this was the master flat. I have very little vignetting, and this is again overstretched in PixInsight, but because of my filter size, the 36mm filters, and the size of the 294 sensor, I didn't have a whole lot of vignetting. I was actually able to stack without flats and not have too much of an issue, but flats definitely do help. So yeah, that's that. So when you use proper calibration data, you know, you have your lights, you got your darks, and you have your flats and your dark flats. I will show you what the Crescent stack looked like after that. So this was a stack of 3 hours on the Crescent in HA. As you can see, down here would have been where I inverted the image 180 degrees. So down here would have been where the starburst was at, and then would have been another starburst here, and then some amp glow down here. But as you can see, all of the amp glow is gone. So yeah. So what I found again was it does have amp glow. You need to take dark frames. Your flats need to be at least over 4 seconds. You need to take flats and dark flats. And for me, specifically, after running through 70 so iterations of trying to get good flats and testing, I found that 20K AU was the best solution for my flats. Okay, so let's go ahead and look at some images that I was able to capture with the 294 once I figured out my flats, dark flats, and all that good stuff. So let's take a look. So the first image was taken back in March. March 16th is what it is, and this was my very first image with the 294. So I guess this is first light. But as you can see, it's the Running Man. This was 15 minutes on luminance, red, blue, and green. So a very short integration, but it was a very bright target, so speaking. So I mean, it turned out pretty good, I think. You know, again, after working the figuring out my calibration frames and whatnot, I can't really complain too much about that. I think it came out pretty good. So that was me testing the Optolong LRGB filters. The next one that I have here is Thor's helmet. So on this one again, I just did a real quick integration on it. This one I had 1 hour and 10 minutes of HA and 1 hour and 10 minutes of O3. So very short integration for narrowband, but I just wanted to test to make sure that I had the filters in correctly, and that everything was working. So this was with the Antlia 4.5 nanometer. I think they call them Edge. So the Edge filters. Again, they're narrowband 4.5 nanometer bandpass filters. So not too bad at all. I was pretty happy with that. That's why I completed it and I stopped. The next one that I have here is M101. So this one was taken, again, all these were taken with the 8-inch RC and the 294. So this one was the first time that I actually tried to integrate hydrogen alpha into a Galaxy image. So this one, it looks like it was 24 hours. So it was about 4 hours on all of the luminance, red, green, and blue channels, and then about 7 hours on the hydrogen alpha channel as well. Put it all together. I'm not good at processing this stuff at all, but you can see, and this is pre-supernova, because this one was taken again March 27th. So this is pre-supernova. Supernova would be right around here somewhere, but yeah, this is pre-supernova. So I thought that one came out pretty good. I was pretty happy with that one. Another galaxy that I imaged was the Bode's Galaxy M81. Again, I attempted to put some HA in there. So for Bode's, this was about 2 hours and 40 minutes on the LRGB channels, and only like 1 hour and 40 minutes on HA. But again, these were all just, I just wanted to kind of test things out and make sure that everything was working and properly. But yeah, this is Bode's Galaxy M81. Alright, so I already showed you this image. This is a little more integration. Well, no, this is not more integration. This is less integration. So this was I was just messing around waiting for things to shoot, and I figured, hey, I'll frame up the Crescent and take a shot at that. So this was like one night's worth, 3 hours of HA on the Crescent. Stretched it out and everything, and looked at it and said, that looks pretty promising, so I may want to come back to this and finish this image off. So that was, and again, this is these are all bin 2 with the 8-inch RC and the 294. Okay, so then I switched gears a bit and I switched over to bin 1. So for bin 1, I was using my 480 millimeter stellar view, the 80 millimeter stellar view, and I went on ahead and framed up Lagoon. So this was in bin 1 on the Lagoon, and this was about 2 hours and 30 minutes of HA. So what, like 6, 12, 15 frames. 15 frames. So I looked at that and I said, that's looking pretty good. So I think I'll go ahead and start working on a project for this. So I started capturing more HA, started capturing some S2, And then when we went out to Alpha Scorpii the last time, which I think was May 20th, I went out and captured the O3 out there. Put all that together and came up with this image here. So this is my SHO, and this was a total of 21 hours and 50 minutes in SHO of the Lagoon. And if you haven't seen the video on that, you know, go back to my channel and check out that video of that night out at Alpha Scorpii. It was very filling. But anyways, all right. So with that, I came back home and decided again that hey, I want to keep shooting the Crescent. So I had 4 or 5 clear nights in a row, relatively close to a new moon. So I shot as much oxygen as I could, and then I shot a little more HA, and I finished off the Crescent Nebula. And that image is right here. So this is the Crescent Nebula, and I really like this image because I think I had 21 hours of oxygen 3 and around 12 hours of HA, and it really, that 21 hours really helped to bring out the oxygen shell. So if we get a little closer here, you can just see all that oxygen. So there's just like a peridermal shell around the brain. So yeah, that and that is everything that I shot or have shot to date with the 294. Since then, I have brought the mount inside, the scope inside, because it's starting to get hot here in Arizona. I think today we were at about 101 or 102. I don't like to leave it in the observatory because inside the observatory it gets a little hotter. You know, it'll get like 110 or so inside the observatory. Oh, and the other thing with this image here I forgot to mention, I did attempt to put RGB stars in. So these stars, I think the stars were like maybe 30 minutes on each channel, R, G, and B, and then I put those stars in. So these stars are not the SHO stars. These stars are the RGB stars. So that was the first time that I integrated RGB stars into an SHO, or this is an HOO, into a HOO image. So I really do like this image quite a bit. I think it came out pretty nice. So I almost forgot about one image that I captured with the 294 and the 8-inch RC. It wasn't a galaxy, it wasn't a nebula or any type. It was a globular cluster. So we need to show those globular clusters some love. So this is the one that I imaged with the 8-inch RC. Let me pull it up here. Right there. We have M13, the Hercules Cluster. This image was only 30 minutes on L, R, G, and B, so 30 minutes on each channel. This is by far probably, at least I feel, the best image that I've been able to capture of M13. I mean, just look at look at the stars. I mean, there are stars everywhere. There are millions of stars in this cluster. But I think I took maybe 30-second exposures or maybe 60-second exposures. I have to go back to my data and look. But yeah, don't ever forget about those globular clusters, because those objects in the sky need love too. But there's my my image of M13. Well, I hope you guys enjoyed the video on the 294. You know, after going through this whole video, I guess I actually did take a lot more images with the 294 than I thought I did. You know, I might not have had a whole lot of integration time, but I think they came out pretty good. You know, I'm really excited. Come around next season for Galaxy season, I'll have the 294 to shoot galaxies with, and I'll also be able to use it in bin 1 with my shorter focal length telescopes to capture you know, different nebulosity. Again, you know, I wanted something that had a smaller sensor so that I could get a narrower frame and narrower cropping of what I was imaging with my longer focal length telescopes. So again, thanks for watching. Stay tuned for more content to come. Don't forget, bing, bing, ding, ding. So don't forget to leave a comment, hit that like button, subscribe if you're not subscribed, and don't forget to hit that bell too, notify, so that you'll get notifications when more content comes out. So other than that, I just want to say thank you, everybody, and I hope you guys are getting clear skies where you're at. I hope you guys are imaging, and that's it.